Welcome to part 3 of finding the equation of this plane. So this method that we're going to use here involves parameterizing the plane. Now you might wonder, validly, what is a parameterization for a plane? And to aid us in this discussion, I have this little cartoon here of some generic plane right here. And so suppose the 3 points we've got are A, B, and C. So A is that point, B is that point, C is this point. So we could label them. So say that like that's A, that's B, that's C. Then the idea is we can come up with like X, Y, and Z in terms of some parameters in order to do that. So we construct the vectors AB and AC in order to do this. And the parameterization P of UV. So U and V are what we would call our parameters, would be A plus the vector AB times some number U plus the vector AC times some other number V. Okay, and so the idea here is that if we, well, you know, if we plug in values for U and V, what we get out are specific points on this plane, and the points are laid out like this grid, like this weird coordinate system that I've got on the plane. So if I plug in U equals 1, V equals 1, then what I'll get is this point. This is like 1, 1. And I'll get, by plugging into the parameterization, the x, y, and z coordinates of that point. Or if I plug in, say, u equals -2, v equals +2, so u equals -2, v equals +2, what I'll get out is like that particular point on the plane. And I can get any point on the plane I want by plugging in just specific values for u and v. Okay, so how do we come up with this parameterization? Well, it's literally just this, right? We start at A, we move some amount in the direction of the vector AB, and then we move some amount in the direction of the vector AC. So we need to figure out what these vectors are. So if A is 1, 1, 1, and B is 2, -3, 3, so the vector AB will just be the point B minus the point A. And so the vector AB will be, so 2 minus 1 is 1. -3 minus 1 is -4. And then 3 minus 1 is 2. And then the vector AC will be point C minus point A. And so the vector AC will be equal to, let's see here, -5 minus 1. So that would be -6. 10 minus 1, that would be 9. And then -2 minus 1 would be -3. Okay. Now, both of these vectors are tangent to the plane. So if we wanted to, we could make a smaller vector that's parallel to AC as part of our parameterization as well. You can see like every number in AC is divisible by 3. Interesting. Okay, so what's our parameterization then? So our parameterization will be our point A, 1, 1, 1, plus our vector AB, 1, -4, 2, times U, plus our vector AC, -6, 9, -3, times some other number, V. And then we can put it all together and say, well, x as a function of u and v would be 1 plus 1u and then minus 6v. Y as a function of u and v would be 1 minus 4u and then plus 9v. And then z as a function of u and v would be 1 plus 2u and then minus 3v. There we go. So now we have x, y, and z coordinates on the plane as functions of these parameters u and v, right? And so the idea is pick a u, pick a v, and we could get any point on the plane. But what if we wanted to know, like, okay, the regular equation for this? Well, we'd have to eliminate u and v from this, and then we can get a relationship between x, y, and z. Okay, so what we could do for this is very cleverly, we can eliminate u and v by just dealing with the x's and y's. We could pick any two of the equations, honestly. And it's just, again, it's more solving linear equations, linear two equations, two unknowns. Here, the x, since we're solving for u and v, we're sort of pretending that the x's, that x and y are just constants. So when we do this, there's a bunch of clever ways to do this. We could solve for u in the first equation, substitute in the second one. I'm going to do something a little bit more clever here to save time. And we could just say, well, if I want to get rid of the u in these two equations, I could do 4 times x and then add it to y. So we could say 4x plus y is equal to, so if we do that, that's 4 times 1 plus 1, so that'd be 5. The u's cancel out, right? Because it's 4u minus 4u. And then minus 24v plus 9v, which would be minus 15v. And then we could solve this for v in terms of x and y anyway, right? So v would be 5 minus 4x minus y, all divided by 15. Cool. We could do a similar thing to eliminate the v. So here we've got a minus 6v and a plus 9v. So lowest common multiple would be 18. So if I do 3x plus 2y, then that'll get rid of the v's. So 3x plus 2y. So what's that going to give us? So 3 times 1 plus 2 times 1, that's 5. Plus 3 times u minus 8 times u, so that's minus 5u. And then the v's cancel out, right? Because it'd be minus 18v plus 18v. And then if we take this equation and solve it for u, we get u. I guess because it's minus 5u, so it would be like, oh yeah. So that would be 5 minus 3x minus 2y, all divided by 5. Cool. So now if we want to know the equation of the plane, we could substitute this u and v into our equation for z, and then clean it up a little bit, and we should get the regular old equation of our plane involving just x's, y's, and z's. So if we sub into z, we get z equals 1 plus 2u, so 2 times 5 minus 3x minus 2y divided by 5, and then minus 3v, so 5 minus 4x minus y, all divided by 15. So a couple of things here. One, right away, that 3 cancels with that 15 to leave a 5 on the bottom. And hey, both of these things have 5 on the bottom. So if I distribute the 2 through the numerator there on the first guy, 10 minus 6x minus 4y. And then I got to be careful here I am subtracting all of this stuff, so that would be minus 5 plus 4x plus y. All of that stuff is divided by 5. So they had the same denominator, so I could just put them with a similar fraction. I can multiply both sides by 5. So if I do that, 5z, this 1 gets multiplied by 5 if I do that, plus 10 minus 6x minus 4y minus 5 plus 4x plus y. And we can clean it up a little bit, right? We could say, oh gosh, how many x's do I have over here? I've got minus 6x plus 4x. So that's minus 2x. How many y's do I have here? I've got minus 4y plus y. So that's minus 3y. And then what are my constants here? Well, the 5's cancel, and I'm left with a plus 10. And then I can move the x's and y's over to the other side of the equation to get it into that sort of standard normal form. 2x plus 3y plus 5z equals 10. And that is the equation of our plane. So what we did here is we used a parameterization for the plane, which might be useful in some other context to get x, y, and z as functions of a couple of parameters. And then we just eliminated the parameters, and then that got us the equation of the plane. I hope you enjoyed that. I certainly did. I got one more of these to go, so I will see you next time for that.